Hey! Ready for round table 24, everybody. And we have 32 people in the chat already, which is pretty awesome. So this particular round table is going to be called Relative Density Kicks Gravity's Bum, specifically titled by Anthony Riley, aka Sleeping Warrior. Sleeping Warrior, are you there?
Yes, can you hear me?
Coming through loud and clear. Loud and clear. I'll give a couple of shout outs to the people in the chat. Who do we have in? We've got Paige in, we've got Lumberjack, Stoned Monkey, too many to count. Julie Bennett, nice to see you in. Thank you very much for supporting me on PayPal as well. Thank you very much. Who else do we have in? Guess Who, Saucy London, F.E. Vader, The Plain Truth, Ute, Ragnar, Savardson, Rodney and Bud. Yeah, too many people to count. Flat Out, Faith, etc. Right, okay, without further ado, last night was an interesting night. It was quite a long 4-hour stream in which we had George Netanyahu and the Rumpus. I gave them free rein to talk about anything they wanted, essentially, and they did. And one of the things that they brought up was Anthony Riley's density tower. And I think, Tony, you actually watched that this morning, am I right?
Yeah, I've not seen George's, I've seen Rumpus's. And before we go any further, I'm going to be fair to Rumpus, right? He had the worst experience with his PC I have ever seen his PC give him. Normally his PC is slick, tidy, you know, it works. But last night's was terrible. And to be honest, I've actually spent longer editing out the bits that were no good, the ums and the ahs and the Jesus Christ, all that kind of profanity, because his PC was acting daft. So it is edited, but that's not because I've cherry-picked anything. It's because his PC was acting daft. So you got to bear with me, because it took me longer to edit the video out, all the bits that we don't need, than it did for me to actually do the video, the response. And I only saw, because it took me that long to deal with Rumpus's video, I've not even had a chance to look at George Netanyahu's, but it's going to be the same kind of stuff. And to be honest, people seem to look up to Rumpus more than they look up to George. So I'd rather attack Rumpus, because he's the one that claims all these silly claims, especially things like gravity's force, and it manifests itself as a force and all this nonsense. Well, I want to address Rumpus, because he's the one that pushes this nonsense. And George has never really waded into this discussion. So even though he did contribute last night, he's not had an ongoing back and forth with us on this. He's quite new to it. So on that basis, I'm just going to disregard what he said, because I've not seen it. It took me too long to get to it. And he's new to the topic. So I'm just going to carry on as though he's not because I've not seen it.
Okay, fair enough. Can't ask any more than that. Well, we've got 55 watching. People are filling in right now, ready to watch this. So, without further ado, episode 24 of the Relative Density Kicks Gravity's Bum with Sleeping Warrior. Are you ready to present your screen?
Am I not already presenting?
You are not already presenting.
Okay, so let me know if you see your screenshot.
Indeed I do. Right, without further ado, I am going to go on to mute, and the floor will be yours for as long as it takes, and then we'll take questions afterwards.
Let's just do a sound check and make sure the sound's coming through. So I'm going to play the first bit. You should hear Rumpus talking. Interrupt me the minute you do.
No.
You didn't hear Rumpus? Okay.
You didn't share screen sounds, did you?
No, it's okay. I know why it is. This is why we test these things. Right, now, let me just do the test now. See if you hear it now.
Yes, we do, yeah. Yep.
Very simple explanation.
Okay.
Yep, coming through. Right, I'm going to transition across, and I'm going to go on mute, and I'm going to leave it up to you.
Okay, so like I say, I feel sorry for Rumpus, because for whatever reason his PC were acting daft last night. So I've had to edit all this out to get rid of all the ums and the ahs. So there's no deception, there's no intentions. I've just got it down to its most simplest form. And this is what we're left with. It was horrendous. So forgive me, but this is the best that I can do with what I've got. So here we go. This is Rumpus's point. It takes about 1.5 minutes.
Right. So you also need to explain. You're going to suggest this is an alternative explanation.
What now?
Yeah, it's not coming through very well at all.
Hang on, let me turn the volume up.
No, not really.
An alternative explanation for gravity.
It might be because...
Few technical issues. Here we go. Try again.
Is that working?
As to how you can say...
Far better. Right.
Right. Let me go to the beginning.
Let's start your presentation again.
Okay, so this is Rumpus's main point. It's only 1 minute 30 seconds.
Right, so you also need to explain, if you're going to suggest that this is an alternative explanation for gravity, then that's a very simple situation to explain. Now imagine here we've got a ping pong ball being held down by a rod, and I then remove the rod. You need to come up with an explanation as to how you can say, having removed this stick now, the ping pong ball, which the average density, obviously the plastic is one density and the air is another, and then you have to explain how the relative density here, as you can see, we've got the ball at one and surrounded by all water. How are you going to then determine what direction this ball is going to go? There is nothing in here going over here or over here or over here. It's surrounded by water of that density, and of course, we've never ever seen an equation that gives direction. Right, so the point is, so here's the density tower with the various objects in it, and people like Anthony Riley are claiming that because these things stay in their particular point, you put an object here of a particular density, it will end up being in the relative density layer that matches its density. But that doesn't explain the situation, the dynamic situation here, where I've got this thing of a particular density. As I say, I released it. There is no relative density equation that will tell you what this ball will do, this ping pong ball in water. We all know what it will do, but there's no equation that anybody who believes in relative density can offer.
Okay, so that's the first bit. He makes 2 points. Basically, the direction. Well, we know that numbers and numerical numbers are, by virtue of the fact that they go up or down, they are linear. Numbers are linear. They go up or they go down. And that's why we can use the phrase relative. So what I'll do now is I'll go to my PowerPoint, TR, and I'll go back to the beginning. Now, I've quoted his words. There is no equation that anybody who believes in relative density can offer that will tell you what this ping pong ball will do. That's not true, and I'll demonstrate why it's untrue. He does make a secondary point about a vacuum, and I'll come to that afterwards. It's my second point in this, which I'll come to shortly. But I want to deal with this word believes in the first instance, because this is not based on belief. I did not have this belief before I did my test. I just realized that if I added salt to this solution, the egg would move, because I could change the medium, and if I manipulated the medium, I could make the egg move. Now, that means that no gravity is doing it. It means that I'm doing it with this density. Exactly the mechanism, I wasn't sure at the time. I now know, but I knew it wasn't. I knew what it wasn't, because I didn't manipulate gravity. I manipulated the density of the medium. But this is not based in belief. This is based in science. This had a valid hypothesis. It had a valid observed phenomena. It had a valid hypothesis. There was a correctly identified independent variable, a correctly identified dependent variable, and both these variables were valid, scientifically valid. There was a performance of a test. Then I was able to accept my alternative hypothesis. I rejected my null hypothesis. This is the backbone of science. This is not belief. So when Rumpus uses the phrase believes in relative density, you can test this yourself. You can get a pint glass, you can pour a bit of salt in some water, and you can make that egg move. It's observable, it's repeatable, it's verifiable, it complies with scientific method. This is not belief. Now, Rumpus uses the density tower that we all use, and we all know, we're all familiar with. And for the purposes of this answer, I've changed the adjectives, the descriptions, these descriptive words, with numbers. And they're all relative numbers. And basically, you divide one by the other. You divide, the cherry tomato, by the density of the cherry tomato, by the medium that it sits in, and then you get a ratio. But it gives you both magnitude and direction, contrary to what Rumpus claims. Now, because the numbers are relative, it means that we don't even need the units afterwards, provided the units afterwards are the same, like kilograms per meter cubed or centimeters or whatever. As long as the units are all the same, it don't matter. You can disregard the units because they're relative numbers. That also means that you can then use one divided by the other interchangeably. You can do the cherry tomato divided by the density, or the density divided by the cherry tomato. That's really important to understand that relationship, because it means that, well, there is nothing else that you need to do to address the claim that Rumpus claims. There is no equation that anybody who believes in relative density can offer. Well, there is. So we're going to work through his example. Now, Rumpus has not been entirely honest, because you can see that he's got the ping pong ball and he's given it density equals X. Well, ping pong balls have a density, and all you've got to do is Google them. Density of a ping pong ball, and it tells you, and you can check it yourself, a ping pong ball has an average density of, and then it gives you a number. You need that number. You need the units to make sure that the units of the density of water in grams per centimeter cubed are the same. So as long as you're working in grams per centimeter cubed and grams per centimeter cubed, the numbers are what you need. So we know that the density of a ping pong ball is 0.084. In contrast, the density of water in grams per centimeter cubed just so happens to be 1. It's not really the best example to use, but as it's his, I'm going to use his, because if I can use his own example, then I can't be accused of not answering the question precisely, comprehensively, and absolutely full. So you need to know the density of the medium and the density of the object. They've got to be in the same units. As long as you get the number, and let's remember that the decimal places matter here. They matter a lot. As long as you get the number, that you need the two numbers relative to each other to address or to answer the question that he makes. There is no equation that anybody who believes in relative density can offer that will tell you what this ping pong ball will do. Well, now we're going to show how it's not true. So we've got the density of a ping pong ball, 0.084, and we have the density of water of 1. So long as both the units are the same, they don't matter. So you can disregard them, as long as they're the same. Because these numbers are relative to each other, it does not matter which way around you divide. The answer will always give you both direction and magnitude, contrary to the claims of the Rumpus. Always, they will always give you magnitude and direction. So it doesn't matter which way around you do it, 0.0084 divided by 1 or 1 divided by 0.084. Doesn't matter which way around it goes. Well, I've got one of the numbers is wrong there, but it doesn't matter. This is just to illustrate the point. And what happens is the number that you get on your calculator when you get it, the numbers before the decimal point give you the direction. The numbers after the decimal point give you the magnitude. And the further away they are, basically it tells you like what's going to happen. So any number that's greater than 1 is going to give you the direction in one way. Any number that is less than 1 will give you the number but go in the opposite way. So a number less than 1 is going to effectively give you up. And we know that up's a relative direction to the observer. Really, it's less dense. A number that's greater than 1 will give you down. Now, I have done this wrong here because I have put one less decimal point in, and they're important, these decimal points. So I've only just noticed it, but it doesn't change the fact. The numbers before and the numbers after give the direction and the magnitude. And so long as a number less than 1 is going to give you an up, or a number greater than 1 is going to give you a down, you always get your direction and your magnitude. But back to Rumpus's claim, there is no equation that anybody who believes, who practices in science, let's put that. There is no equation that anybody who practices in science, that would be me, who practices in science in relative density can offer that will tell you what people. Oh, I'm having practices in science. Anyway, you're supposed to be shush. So, basically, Rumpus's claim is debunked because we can demonstrate it. You just divide one by the other, and then you interpret the numbers that you get in your calculator, knowing that the first prefix is the direction and the second prefix or the suffix is the magnitude. That is the direction and magnitude. That will tell you what the ball will do. So, for instance, obviously I'll use the one that's correct because I've missed off one of the zeros. 0.0084 divided by 1 gives you this. So that less than 1 gives you up. And then the number is effectively like it's 840, or is it 8040, whatever. It's a massive number, so it's nowhere near its relative density point. If this was like 0.9999, that's going to give you a really slow movement, like my egg. My egg will have been somewhat similar to that, 0.9999, because that was a slow movement. But because this is like 884, this is like so far away from its relative density equilibrium point, or its neutral buoyancy point, or indeed its maximum entropy point. They're all the same description. We can tell that this is going to go fast, and it's going to go up. And it's the same for the other one. Even though the numbers are wrong, it doesn't matter. It's still a big number, and the magnitude is fast. It's going up. Then now it's going down, and it's going fast. So again, direction gives you the prefix, magnitude gives you the suffix. As long as you can interpret what them numbers mean, you will always know what the ping pong ball is going to do in this situation. But Rumpus didn't tell people in the audience the density of the ping pong ball. That allows him to argue that you can't do it. To make people think that we're watching that hangout, that there's nothing in this, and it's completely false. It can be done. You've just got to be honest with the figures, and then you can do it, as I've demonstrated. So, play second clip, it says. Here we go. This is his second point to do with the vacuum chamber.
Similarly, if you do have an equation with relative density, it involves dividing one density by another, which means if you have something like a vacuum with zero density, you will never end up with infinity. So this whole thing is complete and utter bollocks. And anybody who can't see that, I'm afraid, is a feeble-minded moron.
Okay, so he says that the whole thing is complete and utter bollocks, but he claims that if you divide something by 0, you get infinity. Well, that isn't true, is it? So what I'm going to do, I'm just going to play this little bit again where he says this bit, because I want to hear people. I want people to hear what he says.
It involves dividing one density by another, which means if you have something like a vacuum with zero density, you will never end up with infinity. So this whole thing is...
So if you divide something by 0, you end up with infinity. Right, so let's go with the apples example. If I've got 5 apples, right? Normally I say if I've got 5 apples and I give you 3 apples. No, if I've got 3 apples and I give you 5 apples, I can't be left with minus 2 apples. That's what I normally say. Well, let's say if I've got 5 apples in the medium of 0, right? And I divide by 0, I've still got my 5 apples. I haven't got infinity, have I? I don't suddenly get all the apples in the world. If I divide 5 apples by 0, I end up with 0. I end up with 5, but I don't end up with infinity. So Rumpus's claim there is totally false, and I can only presume that he's trying to mislead his audience by providing an alternative explanation that sounds ludicrous. And the way he presents that, it does. But if you divide 5 apples by 0, you end up with your 5 apples. You do not end up with infinity the way he claims. So that claim is totally and utterly fallacious. Is he trying to mislead people? I'm going to say he is. I don't believe Rumpus is stupid, but I do believe he's being dishonest and he's misleading people with false representations of mathematics that he wants to apply in a situation that doesn't exist. If you divide 5 apples with 0, you get 5 apples. You do not get infinity. Now, the third point is to do with what he claims, and I'll have to play this little clip because it's not too long, but this is to do with how the maths should be if we do the maths correctly. And in this case, I mean correctly according to Rumpus and the heliocentric model. So let's listen to what he says for how it should be, and then I'll just pull it apart really quickly, and it'll be done within the next 5 minutes.
Right, now...
Oh, by the way, this clip is less than a minute.
Getting on to Anthony's egg thing. Hopefully this bloody thing start behaving. Right, so let's imagine I'm now going to give you the correct explanation of how buoyancy density interacts and how gravity gets involved.
Okay, he's now going to give us the correct way and how gravity gets involved. Now, at this point, I'm thinking, what gravity are you talking about? Are you talking about Einsteinian or Newtonian? Because obviously, since World War I, that's how long ago it was, Einstein replaced Newtonian. It's the curvature, it's the effect of the curvature of space-time. Now, he hasn't said what he's talking about, but we know that he's going to apply weight, so we know he's going to be applying Newtonian principles, and they're gone. they were superseded by Einstein, and we all know what superseded means. Anyway, let's carry on.
So, if you can imagine this object, this egg-like object in this water here, so I'm going to use this notation on the left-hand side here, where rho is the density, which is the mass over the volume, and weight is mg, as we know, which is the mass of the object times little g, which is the acceleration due to gravity.
So, weight. Rumpus is known for saying mass is not a force, weight is a force. However, on screen he has weight, the force due to gravity. Well, we know that gravity is not a force. Albert Einstein said in 1915, when he published his theory of general relativity, that gravity was the effects of the curvature of spacetime. Gravity is not a force. Now, to make my point for me, I'm going to correctly cite George Musa. George Musa is constantly misrepresented by Rumpus. Let's hear what George Musa actually said. Now, I am conscious of copyright strikes for this ranty, so I've blanked out all the background so that it's physically different to how it was looked, how it was originally recorded. If there's any time where you think this might be a bit dodgy, just stop me and I'll stop it. But literally, it's his words. It's all masked out. We need, for educational purposes, we need to hear what he says. It is the total duration of less than 1 minute. And it's snapped up all the way through. It's like it's segmented as well. It's just the key points. But listen to what George Musa says about gravity. This is really important if Rumpus is going to calculate weight with the force due to gravity. You can't calculate weight with gravity as a force. It invalidates weight as a calculation because gravity is not a force. It's the effect of the curvature of space-time. Let's hear George Musa's words in response or in relation to gravity and whether or not it's a force.
Right. So,
I should say though, I'm happy in a broader sense that people care, that this is a topic that people are willing to debate, even if they get some things wrong. I mean, we're all get things wrong in life, and that's not the issue. But to actually have a passion for understanding what is the nature of the universe, I admire. So I think there's a lot that's admirable in even though people I disagree with on the technical details. And Einstein's role here was to really fill in.
So at this point, he's talking about Rumpus when people get things wrong. So let's hear what he says about Einstein in relation to Newton and in relation to whether or not it's a force. So that's what we're trying to work on. Is gravity a force? Because if it's not a force, Rumpus cannot calculate weight using gravity as a force. It invalidates his maths.
Einstein's role here was to really fill in that mechanism. He explained how is it that massive objects, exert what seems to be a force on one another. Now, literally, it's not a force, but generally it's thought that Newton did not take his own law that.
So he's obviously just said, literally, it's not a force. Well, if it's literally not a force, you can't calculate weight with the gravity being a force. It invalidates your maths. 30 seconds left, less than 30.
Literally, that there is a force reaching from one object out to another. However, you can act as if there were one.
So it's literally not a force, but you can act as if it were one. Well, we all know any scenario. Ranty didn't kill his next door neighbour. And even if we act as though Ranty did kill his next door neighbour, that doesn't mean Ranty killed his next door neighbour, even if we act like it's one. So even though George Musa says gravity is a force and you can act like it's a force, that still doesn't satisfy the definition of force. There is no interaction, there is no push, there is no pull. And the final clip he says, this is the most important one. Think about this, what he says.
We can and do, and we must think of Newtonian gravity as a force. That doesn't mean it really is, but we don't necessarily need to work at the really is level.
So I'll close by asking the audience this question. Is the Rumpus working at the really is level? We are. I am. Or at least I'm trying to. I'm not saying that I get everything perfect. But I am working at the really is level. Is the Rumpus working at the really is level? I'm trying. That's the end of my presentation.
Right.
That's the end of my presentation. I've demonstrated that there is formula to calculate what's going to be happening to the ping pong ball. We do not need gravity or buoyancy as forces. Buoyancy is not dependent on gravity. Buoyancy is clearly dependent on the density of the medium relative to the density of the object in question. I've demonstrated the formula. It's a ratio, and it's simple. Doesn't need any further explanations, no further inferences. All of it is completely contained by dividing one by the other and correctly interpreting the results that give you both direction and magnitude. I'm done. Ranty, it's over to you.
Cool stuff, Tony. Cool stuff. Right, let me get some things sorted out here. Right, I'm back. We have had some questions already, Tony.
Fire away.
From Ragnar Stefan Hallordsson. Ranty Flat Earth question. Any citation for relative density?
Any question? What? Say that again. Any?
Do you have a citation for relative density?
Well, no, because all of the science is based around gravity being presumed, assumed, and considered to be a force. This is new. This is leading edge science. This is not something that is mainstream. However, it does comply with scientific method, and in scientific method, you can't infer extra causes. So the only citations that we can give for relative density to equilibrium are practical demonstrations that don't include gravity, and you can test it yourself. Get a pint glass, get a pint glass, get some water, throw a bit of salt in it, get that egg to float in the middle, and then add a bit of salt. That's real world practical science.
Okay, from the same account, what are the definitions of up and down?
Up and down are relative directions. They need the observer to interpret up from down. Really, the correct phrase or the correct units would be more dense or less dense.
Okay, so from the Adam Meakin, interesting. The Rumpus is correct here mathematically, but infinity is only a concept in maths.
No, he isn't, right. So let's do it again. I maybe mashed it up a little bit, but if I've got 5 apples and I divide by 0, I've still got 5 apples. I don't have infinity. So perhaps if you want to reword your question, Meakin, I don't mind answering it again. But Rumpus is not right. It's the answer. I divide by 0.
Well, actually, you answered the very next question, which was, what is 5 divided by 0?
5 divided by 0 is 5.
Okay, from Gently's channel, can you ask what happens when densities are equal? Why is there any force?
When densities are equal, the egg will suspend itself in the middle and it will not move. It will appear to float. And what was the second question?
The second part of that was, why is there any force? Question mark, question mark.
Is there any force? There isn't. If it's not, if you apply Newtonian principles, the second law of motion states that an object at rest. The first law of motion states that an object at rest will remain at rest unless acted upon by a force. An object in motion will remain in motion unless acted upon by a force. Well, the egg's not moving, so there is no force acting on it. Ball earthers tell you that there is a net force where the gravity is equal to the buoyancy. Well, that's an inferred cause. Prove that point. Prove that the gravity is matched by the buoyancy. Because you can't prove gravity because we know it's not a force. So there can't be a net force of gravity and buoyancy because gravity isn't a force. Even if you infer it, doesn't make it a net force. Because as Albert Einstein said in 1915, it is the effect of the curvature of space-time that gives rise to gravitation, and we perceive it as a force. That don't make it a no force. So the reality is there is no forces acting on it. The egg is at its highest state of entropy, or its neutral buoyant position, or its net force of 0.
Okay, so these questions are flying in. Bear with me. So from Gleam, question: are you both aware that there is no such thing as zero density, like the Rumpus said? He needs to be asked how to calculate E equals mc squared on a photon to get a clue.
Well, Rumpus argues that there's no such thing as a vacuum, a perfect vacuum. He argues that even when you get rid of absolutely everything that you can possibly get out of the vacuum, you've still got virtual particles in there. But then he uses a vacuum to demonstrate his point that he claims that if you have a vacuum and something still falls, derpa derpa derpa. But that's like you can't claim there's a vacuum and then you can't use a vacuum after claiming that there's no such thing as a real vacuum because of such thing as virtual particles. Seems to be cherry picking when it suits and then cherry picking when it doesn't suit. It seems to be the best of both worlds. Bit like when you have Coriolis. When they want it to be the Earth's atmospheres rotating with the Earth, it rotates with the Earth. And then when they want it to not rotate with it, it doesn't. Can't have it both ways.
Okay, right. Hang on, wait a minute. I'm copying and pasting all these questions onto Notepad, and I really, literally cannot keep up. So the questions are going to have to stop for a minute till I actually get ahead of all this, because I think we've got at least 6 or 7 to ask right now. So let's crack on. So from Pete Shea, what is Earth if it is not a spinning ball? Do you think it is important to consider what has replaced empty space, or what the nature of the container might be?
I have no idea what the Earth is if it's not a spinning ball. I'm happy with accepting the reality that we're not living on a spinning ball. I don't know what it is. I don't think I need to know. I'm happy not knowing. And realistically speaking, what's the most that most of us have got really to try and work anything out? A P900 and a compass? Ooh. We're never going to know what it is with this kind of money, this kind of resources. I don't think we need to focus on what it is. We need to focus on what it's not. And we can all demonstrate that gravity is not a force, thanks to Albert Einstein. Shout out to Albert Einstein. The ballers deny him all the time.
So from Toady, I have a glass globe filled with water. The ping pong ball is at the centre. What direction will it move in and why? I don't think Anthony can explain which direction.
It'll move in the direction of less dense. So depending on what the scenario is, if he's got a glass ball filled with water, it'll move in the direction of less dense. So whatever direction that is. If you right, so what he's trying to do is trap me into saying up and down. Now the up and down's relative. It's going to move in the direction of less dense. Whatever direction that is, that's the direction it'll move.
Yeah, I saw that. that's how I read it too. So you were spot on there. Marco Green, question: do you consider buoyancy to be relevant, or it's just another made-up thing from the mainstream science which have no true purpose?
Buoyancy is defined. They tell us that buoyancy is dependent on gravity. Buoyancy really is the observation that something will rise. Be it a helium balloon in air, be it an egg in water, something will generally rise. That description, that phenomena, that observed phenomena is generally described as buoyancy, because we know that generally denotes the up rather than the down position. However, buoyancy is dependent on gravity being a force. Well, we know that gravity isn't a force. We don't even need to go any further. Buoyancy, when it's defined and based on gravity being a force, is literally a non-starter. Now, we all observe that the ping pong ball, in Rumpus's example, will rise in the same way that the egg rose. And we call that rising buoyancy, right? But we don't call helium balloons buoyant. We say that helium balloons rise. So perhaps we should describe not buoyancy anymore. We should just say rise, because buoyancy immediately invokes little g. And we know that Rumpus and friends will invoke little g because it's a force in their world. In reality, Einstein says it's not a force, it's an effect. So let's not use the term buoyancy anymore. Let's just use the words up and down or rise and fall. Because the minute you say buoyancy, it's like a gotcha. They go, gotcha, buoyancy is based on gravity. What gravity? It's not a force, you moron. It can't be based on gravity.
Okay. Right, there is a question here, but I'll read it, but I don't expect you to answer it. And to be fair, I think it's just a trick question. Bit of feedback. Yeah, it's just a trick question. So if you divide y equals 5 divided by x and x is infinity, close to 0, what is y? It just seems like it's a trick question that, to get Anthony to ask on the fly. I've asked the question, but I really don't expect you to answer that, Tony, and I wouldn't even expect you to have a guess, because if you guess it and you get it wrong, it'll just be like a trick question. So thank you, Peter G, but,
Just ask the question again, so that just the question, nothing else.
If you divide y equals 5 divided by x, and x is infinity close to 0, what is y?
It depends on what x is, doesn't it? It depends on what your value that's close to 0 is. It would be a big number, though, wouldn't it?
Well, like
I don't know. It seems to be abstract. I don't really see the point in the question, to be honest. But the point is, you can't divide by 0. Now, vacuums are considered to be 0. I know there's virtual particles in there, but that's like pseudo forces. Virtual particles don't exist. Pseudo forces don't exist. So let's not talk about talking in the bullshit. Hang on. Let's use the phrase that George Musa said. Let's not talk about using in the really is level. Let's work in the really is level. Let's not work in the really is not level, eh?
Okay, so we have another question from Ragnar Staffen Halldson. If up and down are relative, why does the egg move up or down according to relative density?
Less dense, more dense. Up and down is the perception of the human. Without the human, it wouldn't be up and down, it would be less dense or more dense. I've already answered that question.
If you put 1 kilogram of styrofoam on a pool of water, it will float. What happens when you put 200 kilograms of styrofoam in the pool? The density has not changed, has it?
Test it. If it floats, it floats. If it doesn't float, it doesn't float. So if you put 200 kilograms of styrofoam...
If you put 1 kilogram of styrofoam on a pool of water, it will float. So what happens if you put 200 kilograms of it?
I have no idea. Put it on and see. I reckon it'd still float.
Yeah, I kind of agree.
Unless you're going to argue... It depends on whether the volume goes up with it or not. If you're going to squash it all into the same volume, you're going to change the density. If you don't squash it into the volume and you maintain the aspect ratio, then it will still float because I'm assuming that you're going to proportionately increase the volume with the kilograms. If you're not going to increase the volume and you're going to make it more dense, then you're going to directly change the density, right? So it depends on whether you mean you're working with the same volume or are you changing the volume proportionately or not. It seems to be a trick question.
Okay, so from Gently's channel, so this is a follow-up from his first question. Please ask Sleeping Warrior, if there is no force, how can the egg be weighed? No force means it can't push down on a scale, can it?
Well, you see, Rumpus claims that scales are a force measuring device. Let's just say I weigh 20 stone and I stand on the scales at the side of the swimming pool and it measures 20 stone. So you morons, you lot think that I've exerted a force on these scales. Well, we know gravity's not a force, so what force is pushing down on the scales if gravity's not a force? Obviously it's my mass, and my mass must be a force if scales are a force measuring device. However, throw the scales into the swimming pool, then try and put 20 stones on them. You won't be able to do it. So if you re-ask the question, Ranty.
If there is no force, how can the egg be weighed? No force means it can't be pushed down on a scale, can it?
Right, so how can the egg be weighed if there is no... Well, when the egg is neutrally buoyant, it can't be weighed. It has 0 weight because it's equal to the buoyancy of the... it's equal to the density of the medium it's in. It has no weight. But if you exert a force up or down, or into the more dense or less dense regions, the further you push it into that region, you're going to be pushing it out of equilibrium, and you will start to register a resistance and inertia. And if you were to use scales to measure that resistance or that inertia, you would perceive there to be a weight there. But there isn't a weight. There is an inertia, and it's based on its position relative density disequilibrium, or it's not nutritional. It's what's the word I'm looking for? It's neutral buoyant position, or its state of highest entropy. But you lot will believe that there's a force there. You're not. You're pushing against the object's desire to return to its natural state of highest entropy.
Okay, so where are we? So from Peter G. If Einstein's claim that gravity is curvature of space-time and the result is acceleration, why can we...
No, it's not. Okay, go on, sorry.
Why can we use it to calculate a force equivalent?
Right, let's be clear on what he means when he says the word accelerate. The effects of the curvature of space-time don't provide an acceleration. They provide a distortion of the space-time, which creates a curved path to the observer, but it's actually travelling in a straight line relative to it. Now, if you're going to curve space-time, you can argue the perception is an acceleration, but the reality is it's still travelling straight with no acceleration. So depending on your perspective, when you make the claim, acceleration, you can argue that there is an apparent acceleration, but actually, real world, that object is still travelling straight, and the curvature of space-time is just creating the perception that there is an acceleration, but really, there isn't an acceleration. It's what we perceive. It's a bit like everything we perceive. Just because we perceive something doesn't really make it true. We have to test it and wiggle it. That's why we have science, because sometimes we can perceive things that are either not there, inaccurate, or wrong. That's why we have scientific method.
Okay, so from Toady. What is less dense then? Globe filled with water. Please explain where less dense is. I challenge you to explain where it is.
Is that a follow-on from his previous question? It must be.
Yes, it's a follow-on, yeah.
Where is less dense? Well, there wouldn't be a less dense in the. I'm trying to picture what he said. He said a glass ball filled with water.
A glass globe just filled with water, so essentially just the whole medium inside of that bowl is water, right?
And what was in the medium?
Water. It was just water with a ping pong ball in the centre, apparently.
Well, if there's nothing in the medium, then there wouldn't be a less dense position, because the medium would be it. So it's difficult to describe without him being in the chat to ask. I'm not really clear on the question he's asking, but if there was something in the glass ball, presumably an egg, then there would be a question there, but I don't think he mentioned anything in the glass ball.
Okay, well, I'll just read the question again. So, what is less dense then? Globe filled with water. Please explain where less dense is. I challenge you to explain where it is. So,
I don't think there is dense in that scenario, and I don't think there's a subject in the medium to be able to move anyway, because I don't think there was a subject.
To be honest, if I was going to answer it, which I'm probably just going to do it for just for shits and giggles now, is that if the ping pong ball is in the centre of this bowl, obviously it has to be in a medium that isn't water, because it would be floating, right? Because it has air inside of it. So if it was less dense, if you're looking for the less dense area, you'd have to say it was above. That would be my answer. Anyway, go on.
Things generally line themselves up in order of density and less dense. So the more dense is towards what we call bottom, and less dense is towards what we call top. And that is a fundamental law of nature. It is that way. We don't know why. It just is. You can claim and believe and preach that it's gravity, but we know gravity is not a force. So however gravity's doing it, you've either got to debunk Einstein, or you've got to rewrite science somehow and dismiss Einstein, or you've got to accept that gravity's not a force, and whatever's causing it, I'm going to say it might as well be God, because there's more evidence that God's created shit. And I say God with a little g in this context, not with a big G. There's more evidence that we are created than there is for any of the nonsense that you guys claim. So it's a law of nature. Like hot goes to cold, nobody challenges it, it just happens. Pressure goes to non-pressure, nobody challenges it, people just accept it. Well, density lines up with the more dense stuff towards what we call the bottom, but it's really relative to the medium that you're in. I'm not really sure how much further I can go with that, because it just always is that way. It's a law of nature in my eyes.
Okay, so an off-topic question. What mark did you get for your thesis?
Not submitted yet. It won't get marked until January, or I won't get the results till January.
Okay, so from Music Man, who seems to be spamming the same question, but I had him in line, seeing as everybody's questions gets put in the order that they were first mentioned. So Music Man, you keep sending the same message, but it's still not going to get answered until right now. When you stand on your head, why does blood rush to your head if the density values have not changed?
Because we're in the medium of air, and the blood is in your body, isn't it? So the density value hasn't changed, your orientation has changed in the medium that you're in. That's like why the stars rotating in the opposite direction in the southern hemisphere. Well, you've turned round. They're not rotating in a different direction, you've changed round. It's exactly the same argument. Let me just address Charlie in chat. He says, ask Anthony if he still uses the 8 inches per mile squared formula, even though it is not exactly correct. 7.98 inches per mile squared is equally as good as 8 inches per mile squared. You still got to see some obstruction, Charlie, and we see way too far. So whether you're using 7.98 or 8, I'm going to say it's insignificant.
Next, massive shout out to Sam Hine again, who's dropped another $20 super chat in right now, and it's a big up for you actually. Question for Sleeping Warrior: could you be any more awesome?
No.
Yeah, everyone seems to say that. Right, let me just get back to these questions. I'm having to keep up. So, yeah, that's just not what I'm looking for. So, the Adam Meakin. Dividing by... Shout out.
Shout out to Joshua. How high is a 10-foot wall? Go on.
Right. Dividing by zero is a concept to enable complex maths. It allows conceptual calculations not achievable in the real world. E.g., you can't share an ice cream between two people.
You can share an ice cream between two people.
Yeah, I knew you was going to say that. Okay. But if I've got 3 ice creams and I have 4 children and they all want an ice cream...
Yeah, one of them's not...
Yeah, one of them's getting 0.
Yeah. I mean, I'll go back to the apples point. If I've got 5 apples and I divide by nothing, I've still got 5 apples. To be honest, Meek, and I'm not sure... I don't really get what you're asking there, because maybe this is going into a realm that I'm not even familiar with. But I don't know, maybe if you want to join, if you want to add him to the call, Ranty, and he can explain his point in a minute. I'm curious to wonder what he's getting at, because I don't tend to agree with him, if I'm honest, but maybe I'm completely missing the point, which is more than likely.
Well, I think Gleam said they'll come on. The Adam Meakin, I did message to ask if he wanted to come on. I know that I've got Martin Leakley coming on tomorrow, and maybe Toadie will join as well, who knows. So, anyway, let's get through these questions. Let's get through what we've got. From Toadie again, why does my takeaway foil container float on water, but crushed into a ball it doesn't? The density and volume are the same in both. What has changed?
The amount of air that's contained within the container. If you remove all the air out of the container by scrumpling it up, then you're going to alter the volume of air that's in it. So that's the reason why. Archimedes' principle. Just let me address Charlie. He says, no, Anthony, the 7.98 inches per mile squared is still not correct. Both are an approximation. Why are you using approximation instead of the exact formula? Well, all right, so let me spit that back to you and say, well, why are you accounting for standard refraction at 76R when it's never, ever, ever 76R? Firstly, it's not based on a radius. It doesn't curve. It follows a deviation from straight in all directions, applying Fermat's principle on the trajectory of light. It deviates from straight, but why do you apply a curve? Who are you criticising here? I don't care what your maths is for your globe. It doesn't matter how accurate or inaccurate it is. What matters is it curved? And you tell us that this formula is supposed to be the way that we can calculate and test it. Well, if you're saying that's not right, you better correct all your peers that are telling us it's 8 inches per mile squared, because that's what we're working on, what you tell us is your model. So if it's not actually your model, let's hear what it is, Charlie, because I'm all ears for that. Are you going to move the globe posts again like all ballers do?
From Pete Shea, what does he think of Geren's change of point of view with regard to gravity?
I didn't know he had changed his view. What is his view?
Again, it's something that would be new to me, so I don't know. But it seems that Pete Shea is aware of Geren's change in stance. Apparently, you're the only person promoting density and buoyancy at the moment.
Oh, right, okay. So in that context, I would say that Geren's the victim of political persuasion and pressure from Bob Nodell, because Bob Nodell practices fake science. He believes that gravimeters are demonstrating a downwards acceleration force, and he refuses to accept and acknowledge that you've got to manipulate your independent variable to prove a cause and effect relationship, which you cannot do with gravimeters. But for some reason, he wants to believe that there's gravity there. So if Geren's changed his position, I'm going to call foul that Bob's basically manipulating it because he's putting pressure on him. The reality is that egg moved because I put salt in it. That increased the density, that therefore increased the pressure from below, and that pushed the egg up. There was literally no evidence of anything else doing anything else. And if Bob thinks that there is, demonstrate it in science by wiggling it. Otherwise, it's nonsense, Bob. We all know it. You're the one that's preaching pseudoscience. If you've infiltrated Geren's mind and he's changed his position, we all know why that is. Shout out to Bob Nodell. Prick.
Okay, so from Marco Green, why do you think density relations manipulate objects' so-called weight? There's no zero weight of an object with weight, but density equilibrium between the object and medium it's in.
Run that by me again.
I know it was a bit convoluted. Why do you think density relations manipulate objects' so-called weight?
Because it's relative density. Like I said, if you're at a swimming pool, you stand on a set of scales. You guys will tell us that there is a weight being exerted because scales are a force measuring device. Throw the scales in the deep end, then try putting your 20 stone on that scales. You're manipulating the medium. It literally, you can demonstrate it time and time and time again. That's the answer. You can demonstrate that this is what is going on.
Okay. From Brian's Logic, question, Anthony, would you agree that if a medium does not have the adequate structure to support an object's inherent density within the object's volume, then the medium won't support it?
Unless it's a solid, yes.
Okay.
Unless one of them is a solid, because you can have styrofoam that's very like it's not very dense. And you can put something that is more dense than the styrofoam on top of it, but because of styrofoam being a solid, then it will support the weight of the more dense object because it's solid. So yes, in general, but in practice, we can demonstrate that less densities with less objects with less density can support objects with more density, provided they are solid and not able to physically move.
Tell you what, you aren't half getting a fair few questions today. It's tough keeping up with these, but I'm trying. LBB Store says, if the current argument is at an impasse, do you agree accelerometers, not affected by gravity in bracket marks, are clear evidence that there is no underside to the mapped regions of our world?
I have no idea. What? Maybe there is. I don't know. I can see why there might be an underside. I can also see why there can't be. I don't know. I would rather just say I have no idea because I don't know how we would even test it.
Okay, so again from Ragnar Stefan Hallardson, can you predict direction, in brackets up and down, only knowing the density? Or do you need more information like where the Earth is?
No. Yeah, it's got nothing to do with it. It's relative density. It's got nothing to do with where the Earth is. You will tell where the Earth is based on the direction of the displacement, because if the Earth is below you, then one will go up, the other will go down, or less dense, more dense, and that will give you the direction in which all of these things line up. Now, if you're going to claim gravity, I may as well just claim God, because nobody challenges why hot goes to cold in the direction that it does. Nobody challenges why pressure goes to non-pressure in the direction that it does. It always does it. Why do people challenge the direction for relative density? If you're going to challenge the direction, I'll just come back and say God, and I'm not even a religious guy, but I'll just come back and say God, because there's more evidence for God than there is for gravity. So let's have God versus gravity conversations, and let's see who wins that. I'll bring John in as my witness.
Okay, so this is an interesting question. Describe, and sorry, this is from Crazations with a Z. Describe how a siphon works using density and buoyancy instead of gravity.
It's just pressure disequilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy instead of gravity.
Well, you can't use density and buoyancy instead of gravity, because buoyancy is dependent on gravity. But you can have the density on one side of the pipe and the density on the other side of the pipe, creating a disequilibrium. And we know that literally, we know pressure causes things to collapse and squash and expand and burst. So if you've got more weight on one side of the pipe and less weight on the other side of the pipe, that's going to create an imbalance. Who said anything about gravity or buoyancy?
I think they just wanted to see how it would theoretically work.
You don't need gravity or buoyancy. All you need is that pressure disequilibrium. But Charlie says no, Anthony, the question of why heat flows from hot to cold is a major topic in physics. Yeah, but it's moot, and it's not contentious in the shape of the Earth.
Nathan Oakley says, is this boring you, Anthony?
Tired.
Nah, you better not be. You're going on an after show in a minute. From Gently's channel.
I rage quit so I can go to bed.
Rage quit, yeah, I know what you'll be up to, dirty boy. While his density math may look like it works, why do objects in low viscosity fluid all accelerate at the same rate? The math makes no prediction for this.
That's wrong. Easy. Who was that? Who asked that question?
It was Gently's channel.
So Gently's channel, if everything accelerates at the same rate in low viscosity fluids, why is it the egg doesn't accelerate at 9.8 meters per second squared? And secondly, in addition to that question, what force, if you're going to claim that there's a force that made the egg move, what force then made the egg stop? Because if it accelerates and then stops, an object at rest will remain at rest unless acted upon by a force. But once the egg starts moving, then an object in motion will remain in motion unless acted upon by a force. So you've got gravity pulling it one way to make it move, or pushing it one way to make it move. What's the other force then that makes it stop? Don't tell me gravity, but it flips around and becomes the opposite.
From 50, air is less dense the higher up you go. If I throw a ball as hard as I can straight up, why doesn't it just keep going up?
It's in the medium of air, isn't it? It's got mass and density that's greater than the value of air. It will get displaced because the medium can't support it. Unlike the egg, that is in a medium that can support it, and it doesn't.
To be fair, that was a malformed question, reading it back. It says, air is less dense the higher you go. If I throw a ball as hard as I can straight up, why doesn't it just keep going up? I mean, yeah, that's just the complete opposite of what you'd expect anyway.
Well, it's because as the air gets less dense, that object that you throw up is getting further and further away from its point of neutral buoyancy or its highest state of entropy. So why would you expect it to carry on accelerating if it's getting further away from its neutral buoyancy position? The only time it stops accelerating is when it gets close to its neutral buoyancy position or its highest entropy state.
From a man like me, what is specific gravity?
I know what specific gravity is. I'll call it unicorn farts.
Is that what you want to quote? Is that that's your answer, right?
I know what he's getting at, and I'm not going to entertain it because I'm going to just say it's unicorn farts. It's like a gravimeter. Gravimeters don't mean what they say that they mean just because the name indicates gravity.
Okay, right. So from John W. Does an electrostatic charge change the density of a helium balloon when applied to it?
I don't know. Test it and see. Maybe it does, maybe it doesn't. I don't know. Oh, actually, it does. Yeah, Zach showed it, didn't he, on Good Times for All? He showed that a helium balloon that was like a little bit more buoyant or less dense than the medium it's in, the air. If he put a charge to it, it appeared to get more heavy just by virtue of the fact that a charge was given to it. So I think the answer to that question might actually be yes, because we can demonstrate that. Shout out to Good Times for All.
Yeah, I was going to mention that to you, but yeah, it was an excellent video actually. Don't check it out if you get the chance. Good Tims, it's Tims. He hasn't put his E in, has he? So it's Good Tims for All. Excellent channel. Gently's channel again. So okay, this is kind of it's one of these questions, but I'll ask it. Could you ask Sleeping Warrior, what's the pressure differential between Earth's atmosphere and 10 to the minus 17 torr?
Absolutely massive. We know that because the 10 to the minus 17 torr, you only need like a minuscule amount in change in pressure, and you can cause adverse effects on the human body. We've seen that demonstrated by, is it the Action Lab, who put his arm tried to put his arm in a vacuum chamber and he couldn't make a good seal. And the minute he made a good seal, he literally broke the seal pretty much immediately because he couldn't create much of a pressure differential before his arm started to physically hurt. So the answer to the question is, how much of a differential is there? Put it this way, we can demonstrate that we can crush a tanker with half of it. And a tanker's made of steel, right? And it's reinforced, it's strong as bloody hell, and we can crush a tanker with half of it. So it's pretty strong. When you look at the vacuum chambers that NASA make, the concrete's like 6 or 7 meters thick or whatever depth it is. That might not be accurate, but it's bloody thick. And when they put it down to the deepest vacuum that they can get, the air will literally bleed through the concrete chambers unless they've got more reinforcements to it. I mean, the differential is vast. And what you guys say, oh, but it's not a negative value, who cares? It's not about the whether it's negative or not, it's about the differential, and the differential is huge.
Okay, so I'm going to ask this sort of follow-on thing from Ragnar, and I'll get to you, Professor Phil Bell, in a minute. In other words, yes, the Earth defines up and down. I did not say gravity, only wanted to know if the Earth is a factor in relative density. I accept your answer, yes it is.
Well, the Earth is a factor because the Earth is more dense than the air. So, of course, it's a factor.
Okay, so from Professor Phil Bell, how does relative density work for satellites?
What he means when he says satellites. Do you mean things that are supposed to be orbiting geocentrically around the Earth? I'm not sure what he means when he says satellites. Depends on whether he's a ball earther or a flat earther, that question. I'm going to assume he's a ball earther. And I'm going to assume that he believes that satellites are orbiting the Earth in space.
Well, yeah, he's actually responding to Lumberjack in the side chat, and he's actually said, putting satellites into orbit sometimes 36 kilometres from the Earth is his job. How does density do it?
They don't do what he's saying, but one sec.
Sure, I'll just do a bit of a dance in the meantime. Right, okay, so wait till Tony gets back. Wow, I think this is actually probably the most amount of questions I've ever received in such a short space of time. I think everybody's waiting to get their hands on Tony for some reason. Can't understand why. Let us know when you're back, Tony.
I'm back.
Good stuff. Right, we've run out of questions, funnily enough, at the moment.
Hey! Can I go to bed now?
No, you're staying up. You're staying up till 12:30.
I'm not staying up till 12:30.
I'm having an early night.
I'll stay up 45 minutes. That's the most, because it's getting late and I'm tired and I don't need to do this because there is no evidence for gravity. You can't even define it, let alone demonstrate it or prove it. And if you can't demonstrate it or prove it, like I can with relative density, then it means that it's pseudoscience.
Okay, right. I'll just do. I'll do one last question from Crazitations again. What causes the pressure the pressure disequilibrium in the siphon?
The weight at the other end of the pipe. I'm assuming he means a pipe siphon. And normally, if you're going to suck diesel out of one tank to put it in another tank, and you might make sure that one's lower than the other, you've got to have less pressure on one side than on the other, and to create that, you have to lift it up. Let me address that guy there, Professor Phil Billy says, ask him how does relative density keep satellites in orbit? Right. Have you looked at quantum levitation? We can make big, massive aluminium plates, thick aluminium plates, basically quantum levitate, and that looks just like an orbit over a flat plane. How does it work? Demonstrate an orbit. You tell me, you prove whatever these satellites you think that they're doing. Just prove there's a satellite there and prove that it's orbiting Earth. Then come back to me. Until you come back to me with a proof that there's something orbiting a sphere Earth, then I don't need to answer anything.
Right, okay, so here's the script. So I'm going to round this up, and then in 10 minutes' time, I'll be starting a chit-chat where I believe we're going to have Gleam join, for at least Gleam. So there's going to be at least Gleam and Tony. So, yeah, 10 more minutes. Tune back in. I'll start the show. And in the meantime, we'll end this one for now. Thank you, Tony, for coming along and doing this presentation. Rather quickly after yesterday. It was a quick response. But that has been Roundtable 24, Relative Density Kicks Gravity's Bum, by Sleeping Warrior. And I shall see you. Hopefully these 175 people will all return in 10 more minutes when I start a new show up, so it won't be on the stream, so it'll be on a new hangout in 10 minutes time. See you all soon.